Okay, hi everyone. So today we're going to look at the Kelantan paper 2, section A. Okay, so question 1. Diagram 1 shows a velocity time graph of a bus with passengers on board. So after 10 seconds, the bus driver steps on the brake pedal to stop the bus. So yes, this is a paper 2, question number 1, which is a very simple question. But it's important for us to remember what does the graph mean. Okay, so if it is a velocity time graph, okay, if it is a velocity time graph, what you expect is what you expect is when you see this one going up, kan, this means okay, so as long as the velocity is a positive value, which is all of this, it is moving to the right. Okay, it is moving to the right. Only when the velocity hits a negative value, then it is moving to the left. So you need to imagine this case as the object is moving to the right with increasing velocity and then continually moving to the right, but with decreasing velocity. Okay, so that's the first thing you need to remember. The positive value of the velocity means that the object is always moving to the right. Only if it is suddenly changed to negative, then it will be moving to the left. Okay, so that's a very important thing. Only velocity time graph, don't confuse with displacement time. That's a different story altogether. Okay. Secondly, because this one is increasing velocity, right? This section is increasing velocity, so this also will be a constant acceleration. Okay, because it is increasing in a straight line. If it is increasing like this, then the acceleration is not constant lah. Okay, this one is increasing, increasing v and increasing a. Okay, the increasing acceleration. And so likewise, the other way around, which is this one, will be decreasing velocity to the right because it's still positive value. Okay, tetapi dia constant deceleration. Okay, so this is V is decreasing, but the acceleration is a constant value, but it is a negative value because the velocity time graph tells us two very important information. The gradient, okay, tells us the acceleration. So if the gradient is a straight line, then the acceleration is a constant value. If the gradient is an increasing one like this, okay, if it is a curve, then the gradient will be increasing. The second piece of information is the area under the graph. Okay, the area under the graph, in this case, okay, will be two triangles. Okay, so the two triangles will tell us the distance traveled. Okay, the distance traveled. Hold on. Okay, now the velocity can be defined as the rate of change of displacement. Okay, this one is speed. So be very careful with this. This is the rate of change of displacement. B, name the type of motion of the bus after 10 seconds. Okay, so after 10 seconds, you're talking about this particular part. Okay, so you can say decreasing velocity, okay, or constant deceleration. Okay, either one of these is fine, decreasing velocity or constant deceleration. Okay, and determine the position where the bus is accelerating. Obviously, it will be accelerating from X to Y. All right, so you write from X to Y. Okay, name the physical quantity. State the physical quantity represented by the area under the graph. This is especially if it is question 1, 2, and 3. This is a very commonly asked question. They will ask you, okay, what does the area under the graph mean? So we need to remember this. For velocity time graph, the area under the graph represents the distance traveled. Okay, not the displacement. Okay, it is actually the distance traveled. Okay. Now, diagram 2.1 shows the experiment used to demonstrate the photoelectric effect. Okay, so this is from quantum physics. Okay, so what is the meaning of photoelectric event? Okay, so again, now photoelectric comes from the two words photo and electric. Okay, so so it's the production of electrons by using light. That's the this one lah. Okay, so it will be production of electrons from a metal surface. Okay, from a metal surface when it is sorry sorry from a metal surface after a light ray. You can say light ray, I guess, light ray or photon ray lah. Okay, after a light ray with a certain frequency, frequency, okay, is shown on it. Okay, the key word for this, of course, is the word electrons and the word light ray lah. Okay, which you can actually say photons lah. After photons with a certain frequency is shown on it. Okay, so when you shine the photons, then after that you will get this one lah. Okay, state one condition for electrons to be emitted from the surface of the metal. This one we've discussed this very long. Okay, and the condition will be that the frequency of the the frequency of the light ray or the photon or the light wave, okay, must be more than the threshold frequency. Okay, so the frequency of light wave, okay, must exceed the threshold frequency of the metal. Okay, of the metal. That's the important syarat lah. Okay. So a beam of light with frequency of yada yada is directed at the metal surface, which has a work function. Okay, so work function is the minimum amount of energy that you need to release the electron, and the rest of it will be the kinetic energy. Okay, so first of all, you want to calculate the energy of light. Okay, so energy of light means the light ray that you said. This would be E equals to H times F lah. Planck's constant is given here. The frequency is given over here. So you multiply it and you get 4.64 times 10 to the power negative 19. Okay, then you want to count the kinetic energy. So remember this, the total energy that comes from the light, okay, is divided into two lah. One must be the work function. Okay, one must be the work function. And then the rest of the energy is converted into kinetic energy. Okay, that is used to like move the electrons lah. So the work function is just to release the electrons. The kinetic energy is what is needed to move the electrons. But both of the work function and the kinetic energy, when you campur together, it must equal to the amount of energy that is provided by the light ray that is shining. Okay, so E, and then after that, some of it will be gone as work function because to release the electron. And then the rest of it will be gone as kinetic energy. Okay, so visualize this. The energy is coming, the light is coming with a certain energy. Some of it is going to be used to release the electrons. That's the work function. And the rest of the energy is used to move the electrons by kinetic energy. Okay, so we are given this function, and I think they should give you, this one there. The photon energy equals to the work function plus the kinetic energy, maximum kinetic energy that there is lah. Okay, so we always assume this is the maximum kinetic energy. So you substitute the E that you got from question number 1, which is this 4.64 times 10 to the power negative 19. Work function usually is given to you. If it is not given to you, then it is just HF naught, okay, which is the threshold frequency. Okay, if you are not given the work function, then you just remember it is the same. Energy is always HF only. It's just which F you want to use. So work function is involved sorry, work function involves the threshold frequency. So you want to count the energy of the work function is HF naught lah. Okay, you need to know threshold frequency. You are not required to remember the threshold frequency. Don't worry. It is a value that will be given to you. Okay, work function, sometimes they may give, sometimes they may not give. In this case, they give. But if they don't give, remember that you can still calculate the work function by using HF naught. Okay, because thanks to our friend Planck, okay, he made it so much easier for us to count the work, to count the energy of a photon. We just times with the h lah, okay, is the frequency times with the h. Okay, it has made it much easier for us. Okay, so you sorry, substitute the work function in here, and then you just minus, you will get the kinetic energy equals to 2.32 times 10 negative 19 joules. Okay, again reminding us that because we're talking about small particles, electrons, atoms, and this, don't expect the energy to be very big value lah. Okay, because it's at an atomic molecular level. Okay, so remember that lah. Okay, number 3, diagram shows a man pulling a sack containing a fruit of mass 7 kg upwards using a pulley with a force. Okay, so he's pulling this with a force of 68.67 newtons. Okay, the forces acting on the sack are in equilibrium. Okay, so this is a very important thing. So the forces acting in the sack equilibrium, the sack is not going up and not going down. Okay, the sack is not going up and not going down means it is equal. Means that the tension of this string is equals to the weight of the sack. Which also means that since the tension of the string is caused by this force, I can say that the force upwards is 68.67 newtons and the force downwards is also 68.67 newtons. So the weight of the sack is 68.67 newtons. Okay, yeah. And if you don't believe, I guess you can 7 times 9.81 lah. Okay, because this fruit, the sack is 7 kg, right? So the weight is 7 times 9.81, which is amazingly equals to 68.67 newtons. Okay, so there are many clues in the question that already tell you that, you know, the weight is equal to the force. Okay, so what is meant by forces in equilibrium? Forces in equilibrium basically is just the net forces, okay, acting, the net force acting on an object is 0. Okay, that is forces in equilibrium lah. Okay, so based on diagram 3, sketch the free body diagram for the two forces acting on the sack. Okay, so this is the sack. Okay, the two forces will be the weight and the force upwards lah. You can also write tension on the spring. I guess tension is a better word lah. Okay, tension, okay, and then weight. Okay, because this one is the tension that is caused by this force. Disebabkan oleh the force. So you don't say force lah. I think it's better to say tension. Okay, two objects that have 0 resultant force cannot. Why two objects? It's only on a single object. You cannot say two objects with. If you say two forces, with 0 resultant force, also wrong, because it cannot always be two forces. What if there's 3 forces acting on it? Let's say, for example, I have 2 strings and 1 weight. These are 3 forces already. So I will say a situation where the total forces or the resultant force, okay, or if you don't want that force, then you can say the resultant force acting on an object is 0. Okay, don't say 2 objects, definitely not 2 objects, just kaitan tu dengan 2 objects. Okay. So what is the value of the downward force acting is 3B. I wrote that the answer is 68.67 because I've already explained it earlier. So what is the force that must be applied by the man to move the sack up with an acceleration of 2 meters per second? So now there's going to be acceleration, which means it's not equilibrium already. Okay, so the net force, okay, is F minus 68.67. because I want it to accelerate and I don't know what is the force that I must kenakan. So I just assume that the net force, okay, the net force is F and then minus the 68.67, which is downwards. Okay, and according to Newton's second law, remember this is net force equals to ma. So F minus 68.67 equals to 7 times. We want an acceleration of 2. Okay, so you calculate this and you should be able to get 82.67 newtons. Okay. So again, now remember, if there's no acceleration, weight equals to the force, no problem. But if there is an acceleration, you need to think about which direction is the force, which direction is the acceleration. If the acceleration is going up, then it is the up minus down. Okay, let me, sorry, okay. If the object, there are two forces lah, okay, W. If the object is accelerating up, then your net force okay, must be F minus W. Because it's going up. So obviously the force upwards is bigger than the weight lah. Okay. If the object is going downwards, then the net force is what? The net force must be W minus F. Because the weight is bigger than the force. So whatever it is, your net force value must follow the direction of your acceleration. If the acceleration is going down, then it is the down minus up. If the acceleration is going up, then it is the up minus down. Okay, so always follow the direction of the acceleration. That will help you to determine the net force. Okay, don't be so stuck. It must be F minus W or it must be W minus F. No. Okay, everything depends on where is the direction of the acceleration. Okay. All right, diagram 4.1 shows two bodies P and Q of different masses at a distance r between each other. Okay, so the gravitational force F can be explained by Newton's universal law of gravitation. I know what's the first question. Apakah? Yeah. Okay, state Newton's universal law of gravitation. So this one is a very long one. Okay, and Newton's universal law of gravitation has two components to it. Okay, which must be said lah. Okay, so the gravitational force, okay, between two objects is, okay, directly proportional to the product of the masses and inversely proportional to the square of the distance between the two masses. Okay, square of the distance, because the formula is F equals to G m1 m2 over r squared. So it is directly proportional to the product of the masses and inversely proportional to the square of the distance between the two masses. Okay, it's a very long definition, but knowing the formula will help you to write down the definition. Doesn't matter if your definition is so kucak-kacir like saya tahu macam mana mau tulis ini, but just use the formula to help you to this one. Okay, if you want to say directly proportional to the mass 1 times mass 2, I think also can be still accepted lah. If you don't know the word product, okay, mass 1 times mass 2, and then inversely proportional to the distance squared. Okay, some people can say that one lah. Okay, I don't think it's a problem because I think you are getting the relationship right. So my definition is not wrong, and in this particular paper, the formula for gravitational force is given lah. So it can be an advantage to you to refer to the formula, okay, to help you lah. Okay, so next, so calculate the weight of P and Q. So the answer is there, 78.48 N. So the mass is given, one is 8 kg, one is 20 kg, so you can calculate the mass yourself lah. Sorry, calculate the weight yourself. Okay, obviously the 20 kg is like so much bigger lah, kan? So obviously the weight is also much bigger lah. Okay, then you can calculate the force between the two of them. Okay, and you find that the force between the two of them, when you calculate, okay, R is given as 175 cm, but you want to convert this to 1.75 meters. Okay, so you calculate using the formula F equals to G m1 m2 over R squared. Okay, then you will get a value of 3.48 times 10 to the power of negative 19. Okay, the question now is, are they attracted to one another? Okay, so the question is a very interesting question. There is a force of attraction. Okay, so don't doubt that. Memang ada daya tarikan. But the question is, adakah mereka tertarik antara satu sama lain? Are they attracted to one another? So the answer will be no. Why? Because look at the weight and look at the force of attraction. Very logical one, this question. Okay, this is a very, there is some attraction, definitely got attraction one, but because the weight is so much bigger, okay, the weight is so much bigger than the force of attraction that it like totally makes the force of attraction useless. Okay, so you can say because the weight of each one each body, okay, the weight of each body is much bigger, okay, than the gravitational force. Yeah, I know. Maybe you want to say way bigger lah. Okay, sugati kamu lah, doesn't matter. But that's the idea lah. Okay. So even if, let's say there are two people that are sitting next to each other, there is a gravitational force that that is acting on the both of them. But because our weight is so much bigger than the gravitational force, okay, thanks to the value of G lah. Look at the value of G times 10 to the power negative 11. Okay, so thanks to the value of G, the gravitational force between people is actually very small. Imagine if the gravitational force between people is big enough, that means no matter what we do, we're going to be attracted towards one another. We're always going to keep bumping into one another. So please thank God for the weight that you have. Because of your weight, you are able to avoid bumping into each other. Otherwise, there'll be no such thing as social distancing. It'll be impossible for us to socially distance because the force between P and Q is too weak. Can? Also can? The forces between these can lah. I mean, it's just saying the same thing lah. But I like, because it is, I like this question. Sorry, I like this answer. Wow, saya puji diri lah kan. I like this answer because it is related to the weight. Because I have been wondering, why did they ask us to count the weight? Like, what's the point of counting the weight? It has nothing to do with question number 2. And then I realized that I think it does. It is actually meant for you to think that, oh, okay, look at the weight and look at the gravitational force. Okay, the gravitational force is there. You cannot deny it. Memang ada. But our weight is so much bigger that it makes the gravitational force look like, lemah. Like no use one, the gravitational force. Okay, so I wouldn't say your answer is wrong, Sean, but go ahead. I think it's fine. But I would like to use this answer because I've been wondering why did they ask us to count number 1? Like apa gunanya lah. Okay. Okay, C. Diagram 4.2 shows a metal ball of mass 75 grams is tied to the end of a string 0.8 meters long, which is rotated in a horizontal circle with a speed of 1.8 meters per second. Okay, so this is obviously centripetal force. Okay, so the centripetal force formula is here. The tension of the string is actually because of the centripetal force. Okay, so centripetal force is one of the very few forces that the mass is the mass of the thing that is orbiting, not the mass of the center. Okay, so the mass of the object that is orbiting. Okay, remember this lah. because a lot of the other ones are, for example, linear speed is square root gm over r. Okay, escape velocity is 2 gm over r square root. But this m, okay, is not the mass of the satellite, is the mass of the planet. So centripetal force is one of those forces where if it is a satellite, then it's the mass of the satellite that we take. Okay, so be very careful about which M we're using. And I think I mentioned before in a previous class, it helps to look at the formula because the formula should tell you whether you need to use a big M or small m. Oh no, they didn't give even the rest. They just give, okay, fine. They, they just give centripetal force. So wow, they give centripetal force means you must use centripetal force. Okay, I think that's even better. If they give you all the formula, they'll be like, which formula am I going to use? Okay, so you calculate this. Don't forget to convert the 75 grams into kilograms. Okay, the R is 0.8. Yeah, mv squared over R. Okay, the V is the one that you squared. So you should get about 0.304 newtons. Okay, so don't be confused by the word tension of the string. We have looked at a few examples of this before. The tension of the string is always this way, which is the same as the centripetal force. Okay, the centripetal force is the force that enables things to move in a circular motion. Okay, and don't forget also what happens if, let's say, the string terputus. Okay, so you please go and check back the answer The word tangentially in a tangential direction, blah 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 blah. Okay, go and I would suggest okay, go and memorize that answer. Okay, oh, I'm not done. Sorry. So 5.1, 5.2 show the ray diagram for an upright object that is two different distances. Okay, so everything is over here. Okay, you can check it out. So name the light phenomenon involved. This is mirror. Okay, so mirror will obviously be reflection. Okay, mirror will be reflection. Okay, the answer for the rest is here. I guess you can compare and do the relation yourself. Okay, the bigger the object distance, the smaller the image distance. The bigger the object distance, the smaller the size of the image in that order. Okay, don't get the order wrong. The object distance determines everything. Okay, the ray diagram. Let's talk about the ray diagram. For most diagrams, okay, for let's say if for a diagram like this, okay, you want the first ray to here, make sure it touches this line, not the lens. Okay, and then the first one will be, it will be reflected through F lah. Okay, this is the first one. Now, I notice that a lot of people, when they draw, they always tend to forget the arrows. Okay, arrows is kind of a very important thing because it tells us where the light is going, going towards the mirror and reflect. Okay, that's the important thing. The second one will be, it will pass through C. Okay, that is a very normal one. So the second ray will be, it will pass through, oh, sorry. Okay, it will pass through C, everybody, and you need to make sure that it touches here. Okay, it will pass through C and actually, yeah, it will just pass through C. Okay, so it will be drawn like this and comes back at C. So the so it is shown here. Okay, I still don't know why I have to so weird. There's a third one. Okay, there's a third one, it passed through F and then after that goes into parallel. So the third one will be it's so tiring. Okay, the third one will be passes through F and then after that goes parallel. Okay, so it should be something like this. So you see, wow, almost kena. There's somewhere over here kena. So this is where the image is. Okay, but not every diagram will allow you to draw all three lines. Okay, but there are two things that I want to mention first. Okay, before we look at the actual question. So in most cases, you should be able to draw something like this. Okay, except for cases where the object is in this region. from F, okay, until this one, these are special cases. Okay, anything beyond F, you can draw and you can draw at least 2 lines. I would suggest actually follow the one in 5.1, 5.2, which is draw the red color and draw the green color. If you can draw the center, the blue color one, then go ahead with it. Okay, but now the problem is, what happens to an object that is very, very near to the mirror? Okay, so that's what we want to see. Let me rub this off first. Where is, oh, okay. So the first ray is always the same. Okay, it will be sorry. The first ray is always the same. It will be parallel and it will bounce back towards the focal length. Okay, so this is the first one lah. Parallel, bounce back towards the focal length. So don't forget to draw the arrows. Now the second one is a bit hard lah, because the second one is it should be go towards the F and then parallel. But now you cannot have the light going towards the F because it is supposed to go towards the mirror lah. Okay, so you have no choice. You have to draw the one that goes to C. Okay, so you take the top of the object and you connect the C. Okay, and you draw. Okay, just draw and you continuously draw until here. So don't forget the one that goes to C must go back and come back. Okay, but you will find that this section, they will never meet because they're going further and further away. So what you do is you extend to the back. And when you extend to the back, you need to make sure that you extend using dotted lines. Okay, likewise the same here, you extend using dotted lines until it meets somewhere here lah. Oh, sorry. It cannot be like this. It has to be dotted line also. Why? Because this is a virtual image. Okay, complete the ray diagram to show how the image is formed. So anything behind the mirror, everybody, this is not lens. Okay, I've talked so much about lenses today. We need to talk about mirrors. So mirror, anything behind the mirror will be virtual. Okay, so this is virtual, up, upright, and magnified. Okay, in case they ask for the characteristics of this image. So, if anything, remember this. For mirror, actually even for lens, but specifically for mirror, okay, anything that is behind this F, sorry, hold on. Anything that is behind this F, okay, will be anything that is behind this F, okay, will be, you can form an image lah. Okay, but anything that is in this particular section, okay, the image will be behind one. Okay, will be behind the mirror lah. Okay, will be virtual, upright, and magnified. Okay. All right, number 6, diagram 6.1 and 6.2 show two circuits with battery P and battery Q, which are used to determine the EMF and the internal resistance. Wow, isn't this a familiar situation? Resistor used in both circuits are the same. Okay, wow. Look at how many batteries they have, and they can reach until 9.6 and 4.8 amps. In the meanwhile, we are using one battery and trying to reach how many amps? 1 amp. My goodness. Okay. So anyway, what is meant by the electromotive force? Okay, the electromotive force is the work done. Yeah, I know. I like to use the word energy, right? Okay, but it can also be said work done lah. Okay, or energy needed. Okay, by an electrical source. This is different from potential difference. Okay, the key word is this. Sorry, the important word is by an electrical source. Okay, so work done by an electrical source to move 1 coulomb of charge across a complete circuit. Okay, so this is the this is the two key differences, the two keywords that are different from potential difference. Potential difference is work done to move 1 coulomb of charge between 2 points. That's it. Okay, but for electromotive force, there's a lot more stuff. Work done by an electrical source to move 1 coulomb of charge across a complete circuit. So it's not just 2 points. Okay, it is a complete circuit. So let me write the potential difference one in green. Okay, so work done, then there is no such thing as in green, in blue, by electrical source to move 1 coulomb of charge between, let's use the word across since we are using across also. Okay, across 2 points on a circuit. So the one in blue is potential difference. So work done to move 1 coulomb of charge across 2 points on the circuit. That's potential difference. But electromotive force is got one additional keyword, work done by an electrical source. Okay, by an electrical source to move 1 coulomb of charge across a complete circuit, which is the second difference. Okay, so although both potential difference and electromotive force, the unit is volt, okay, the definition is different. Okay, just be careful with that. Okay, the electromotive force of the battery is the same as you can see here, and they also, hold on. Oh, sorry, it is both the same. Okay, so that's how you know. So the reading of the voltmeter, everything is 6.1 more than 6.2. Reading of ammeter is also shown. Everything is given over here. This will be quite straightforward. Now the relationship here is a bit interesting. Okay, so the voltage drop and the ammeter reading is inversely proportional. So the bigger the voltage drop, the smaller the ammeter reading. And the internal resistance will be the bigger the voltage drop and the bigger the internal resistance. Okay, this is probably the one where it is not so clear. Oh no, sorry. Okay, this is probably the one where it's not so clear because you need to think a little bit more. Okay, if there's a bigger voltage drop, means that you need more energy to cross over the battery. Okay, that's why there's this voltage drop. Okay, so the bigger the voltage drop, the bigger the internal resistance. Because that means not all the voltage is going into the circuit. A lot of it is being spent just to overcome the battery resistance. Okay. Now diagram 6.3 shows the dry cell with EMF 1.5 volts, internal resistance, yada yada. Now, this is also very familiar, right? If an identical bulb is connected in parallel to the circuit, slightly different than what you had on the 15 the other day, right? Okay, that one is if you connect another battery parallel to this one, but now this is if you connect another bulb parallel to the circuit, means you put another bulb over here. Okay, what will happen to the ammeter and voltmeter reading? So the voltmeter reading will decrease, okay, and the ammeter reading will increase. Okay, why? Because the most logical one, okay, the most logical one is obviously the ammeter reading. Okay, why will the ammeter reading increase? Because when you arrange things in parallel, the more things you arrange, the smaller the resistance becomes. And when the resistance becomes smaller, okay, the total resistance decreases. Okay, when the total resistance decreases, more current can flow. Okay, there will be an increase. Okay, so that is the answer for this. Okay. 7.1 shows a decay curve of radioisotope sodium 24, Na2411. Okay, over here is the decay curve. What is meant by half-life? Okay, half-life is time taken for radioisotope. I wouldn't say radioisotope. Time taken for Time taken for the activity. I like the word activity better because we're using activity. So time taken for the activity of a radioactive substance to reduce to half of its initial value. Okay, the key word will be half of its initial value. Doesn't matter if you want to say mass of a radioactive substance, you want to say molecular mass okay, or you want to say the weight, weight I wouldn't say okay, mass okay. As long doesn't matter whether it's activity or mass. I like the word activity because we are already using activity in this graph. Okay, but the key word is to reduce to half of its initial value. That one must be there, or half of its original value. That also can be acceptable. Okay, that is the keyword for half-life. So determine the half-life. Okay, so you need to know the starting. Starting is 2000. So half of 2000 will be 1000. So you draw the graph. Okay, and you find that the half-life is 15 minutes. Okay, this will be 1 mark, and obviously the question say this one no, show on the graph how you determine. So never miss an opportunity to show on the graph, otherwise you're going to lose that 1 mark. Okay, so yeah, and of course make sure you write the correct unit Don't just write 15 what, okay, 15 ringgit, 15 cent, okay, 15 seconds, no, 15 minutes. Okay, determine the activity of this one after 3 half-lives. Okay, so we can start with the original one 2000. 1 half-life is 1000. Second half-life 1000 divided by 2. Okay, dia bukan janjang arithmetic. It is not an arithmetic progression. It is a geometric progression. Just always divide by 2, divide by 2. Okay, you must never write 0. There can be no such thing as 0 activity. People will see this and they will logically think, oh yeah, that is correct. 2000 pergi 1000, after 1000 0 lah. So habis sudah. But it's not. Okay, half-life is half half. It's always kena half. So half of 1000 is 500. Half of 500 is 250. Okay, there will be it. Okay, it's only 1 mark. Actually, there's no mark for this working at all. Okay, we just write 250 or so. As long as you don't write 0. Okay, just remember there is no such thing as 0 activity. Okay, there will be 0.00000000001 activity ada. Tapi 0 activity totally is memang out of the question. Okay, 7.2 shows a cross section of the nuclear reactor model. Okay, this is obviously my favorite topic. Okay, so 3 reactors model. So you have you have technetium and you have uranium. You have the control rod, which is graphite and boron. Okay, so you want to know which is the suitable one for control rod and the fuel rod lah. Okay, so obviously the fuel rod, the best will be uranium lah. Okay, why uranium? Because it has a longer. Usually uranium is associated with a longer half-life lah. Okay, whereas if you see from natrium, from sodium, sodium the half-life is only 15 minutes. Every 15 minutes, it's going to reduce into half. That means dia akan cepat habis. Okay, habis. Dia akan cepat habis. Which we don't want. You cepat habis means every time you have to keep refueling. So we want uranium 235. Okay, because it has a longer half-life. Okay, or lasts longer. Okay, either one of these will be fine lah. Okay, secondly, the control rod should obviously be boron lah. It cannot be graphite because graphite is the moderator. Okay, moderator and control rod is different. Okay, the control rod, the moderator is used to slow down the speed of the neutrons. That's graphite. But the boron control rod is used to control. Is used to apa itu menyerap. Is used to absorb the neutrons. Okay, so be very careful. Boron, okay, So control rod ada dua lah. One is boron and the other one is cadmium. Okay, these are the two that are famously in the books. Is famously known as the control rods lah. You can either use boron or cadmium, but the function of the reason why we use boron, okay, so it is able to absorb neutrons, okay, to control the rate of reaction. Okay, to control the rate of reaction. Okay, but moderator is usually just graphite, and moderator is used to slow down the electrons. Okay, so it's a difference. Satu tu menyerap, satu tu memperlahankan into neutrons. Okay, and the moderator bahannya adalah graphite. Okay, so if you don't know the difference between the control rod and the moderator, which I don't know whether they're showing here, or it's not shown, sorry. If you don't know the difference between the control rod and the moderator, they have two different purposes. Moderator is kasih slow. Kasih moderate lah, you know. Moderate maksudnya menyederhanakan, bahkan moderate is kesederhanaan. Moderation lah, okay, is kesederhanaan. So you want to slow down the neutrons. Okay, so use a moderator for that. Boron is, it just absorb the neutrons. So the control rod, which is either boron or cadmium, is more of mengawal bilangan neutron yang ada. Okay, manakala moderator is mengawal kelajuan neutron. Okay, it controls the speed of the neutron. So you want to make sure that you know the difference between these two. Okay, the word is there, you know, control. One is to control. Apa yang control? The rate of reaction lah. Okay, control how many neutrons. Moderate is control the speed. Okay, moderate the speed. Okay, supaya kau tidak terlalu laju. Okay, pergi this one lah. So be very careful with this. It's very specific one. Okay, it's just like apa itu? Just like transformer lah. Okay, why laminated? Why is it soft iron core? Okay, so macam itulah dia punya jawapan. Okay, so after a while, if you answer this enough, can. Okay, so based on the answer, obviously the best would be R. Okay, last question. Diagram 8.1 shows a ship in front of a cliff. What is the ship doing in front of a cliff? The ship sounded the horn and the echo was heard 9.4 seconds later. Okay, so horn, and then after 9.4 seconds later, dia dengar balik. Okay, wow. So state the wave phenomena involved in the situation. Okay, so this will be reflection. Okay, and it's interesting that this paper, 2 times they ask you the same question. This one reflection, then remember just now question number 5, I think. It's also reflection. So it's like, oh, okay. All right. It's a bit strange that they will ask the same phenomenon twice. Okay, but oh well. So explain how the echoes can be used to determine the distance. Okay, so so you say the time taken, okay, the time taken between, sorry, the time taken to receive the echo after the sound has been produced is used in the formula sorry, formula D equals to VT over 2. Okay, to determine the distance. Okay, the time taken to receive the echo after the sound has been produced is used in the formula D equals to VT over 2 to determine the distance. Usually, if you mention just D equals to VT over 2, sorry, not just mention without any context now, mention and beri sedikit penjelasan, you know, usually will get you the 2 marks lah. Some, of course, will be, oh, okay, a sound is produced and then the echo is heard and the time taken between the sound and echo is recorded. After that, the time is used in the formula, blah, 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 to determine the distance. Something like that. Okay, I'm just giving a slightly shorter form of this. This formula, okay, let's take a look at the formula list in front. Okay, this formula, I don't see it. Okay, I see the speed of the wave formula, okay, but I don't see the Vt over 2. Okay, yeah. So you kind of, I would say it is a slight advantage if this question comes out, okay, that you memorize this formula. Because actually, even in the old syllabus, I would tell my students, this is one of the formulas that jarang dia kasih keluar. Okay, this is a very rarely dia akan kasih keluar. Because dia biasanya akan bagi apa tahu, velocity equals to distance over time, or S over T lah. That one usually they will give. So, mereka mengharapkan that you know how to derive this yourself. Okay, so just remember anything to do with echo, okay, atau reflection of waves, okay, you want to determine the distance between, let's say, the airplane and the air control tower. So the formula is always this: D equals to Vt over 2. Okay, a kelawar or a dolphin with a tembok or something lah. Okay, also this situation, D equals to Vt over 2. So you need to remember this formula lah. Okay, so the ship is 1,600 meters away from the cliff. So they already give you the distance. Wow, 1,600. Okay, you have the 9.4 seconds. So you can determine the speed of the sound of the wave. 1,600, D equals to Vt over 2. 1,600 equals to V 9.4 over 2. Sorry, 9.4? Yeah, 9.4 seconds. Okay, over 2, you should get the answer V equals to 340.43 meters per second. Okay. This one is a very commonly asked question. Sorry, this formula is a very commonly asked formula in both paper 1 and 2. Okay, so I would say that it is an advantage to you if you can remember this formula. Okay, especially because they don't usually give this formula in the formula list. Okay. Diagram 8.2 shows a dolphin uses wave to detect its prey. Then like this lah. Okay, so it may be like this case, So also the same. You want to determine the distance between this, right? So the dolphin will hear the sound again 7 seconds later. What is the distance? Okay, think something like that. Sorry. Okay, so based on the following aspects, this suggestion is how the dolphin is able to detect its prey more efficiently. Okay, give one reason for the suitability of this aspect. Okay, so the type of waves. So most people will say sound waves. Okay, because they think about the horn and then sound waves. Okay, but this is more of a ini lebih kepada fakta lah. You can't really use logic out of this lah. Okay, the answer will actually be ultrasonic waves. Okay, bats, dolphins, they communicate with each other, okay, by using ultrasonic. Ultrasonic means it is beyond our, it's very, very high frequency lah. Okay, so that's I mean, when you think about ultra, it's like, wow, Ultraman or ultra power. Okay, so why is this so ultra? Okay, because it is high frequency, high frequency. Okay, high frequency usually is associated with high energy. Okay, so those are two possible reasons that you want to this one lah. Okay, and yes, the next one is frequency of the waves. So the word ultra itself, I wish it was not extra lah. It's so much easier to remember. Extra sonic waves. Wah, senangnya mengingat. Tapi it's called ultra. Okay, so frequency of the waves must be high. Okay, because of the word ultrasonic waves lah. But you don't say high frequency, and then the reason also is high frequency lah. Jangan lah. Okay, it's asking for trouble. So you can always say high energy. And high energy waves, okay, like ultrasonic waves, are usually associated with can travel further, okay, can propagate further, okay? Because it has high energy. So dia boleh jalan lebih jauh lah. But we don't say because it can walk further or travel further. Remember, propagate is a very specific wave terminology. So we don't say the wave move, we don't say the wave walk, we don't say the wave travel. Okay, better to say the wave propagate. Okay, the wave propagates further. Okay, that's why we use high frequency waves like ultrasonic. Not we use, sorry, that's why dolphins and bats use. Okay, and that is a very important distinction between this one. Propagate faster, travel faster. No, I don't think it has anything to do with this one. Faster. Faster is speed of waves. E equals to F lambda. Uh, wave speed actually is the same all the while. Yeah. So speed of wave is 330, 330 meters per second. Speed of sound wave, sorry. Speed of sound wave is about 330 meters per second. And the value doesn't usually change because remember the relationship between frequency and wavelength. When the frequency is high, the wavelength is low. When the wavelength is low, when the wavelength is high, the frequency is low. So that balance gives is because of the fact that the speed of the wave is a constant. Actually, it is a constant. Yes, I know we calculated just now as 340.43. Okay, maybe this is a slightly special sound, but actually sound wave, the speed of sound and the speed of light are actually constants. Okay, speed of light is about 3 times 10 to the power 8 meters per second, right? Speed of sound is about 330 meters per second. I think so lah. Sorry, speed of sound. I think so lah. Okay, I think so. But I know that the speed of sound is a constant. So if you want to say the answer travel faster, I would probably mark it wrong. Because the frequency doesn't have to do with whether it goes faster or slower. Travels further is a better answer. Okay, thank you for the question. It's a good question. Good question. Good that you brought it up. So yeah. Okay. That's it for today. That's it lah. That's it for this Kelantan paper. We have only one more paper to go, which I will do in another session.